Okay, so let's finish off this hypothesis test here. So back to the question. We have the question, do women talk more than men? So here's the raw data for the women. Here's the raw data for the men. And we're on part B. Test the hypothesis. They tell us mu1 equals mu2 for the null. And then the alternate mu1 greater than mu2. What do we conclude? Okay, so in part one of the video, we wrote out the null and alternate here. The null mu1 equals mu2. The alternate mu1 greater than mu2. So now on to step two is get that raw data. So there's six things we need to compute here. We need x bar 1, which is the mean of the sample of women. We need S1, the sample standard deviation of the women. We need N1. Well, N1 we already know. That's 27. They just tell us that in the problem. Okay, we also need x bar 2, we need S2, and we need N2. So that's the mean of the sample of men, standard deviation of sample of men, and the sample size. And the sample size, it told us was 20, right there. Oh, and while we're at it, what's the degrees of freedom? So the degrees of freedom, um, uh, in the textbook, it mentioned two ways of getting degrees of freedom. The hard way is use some computer, use some real fancy formula to get degrees of freedom, or the simple way, just do n minus 1 of the smaller sample. And so in this case, that would just be our smaller sample is this one, the men. So 20, 1 less than that is 19. So degrees of freedom is 19. Okay, so now the means and standard deviations. I downloaded the data onto an Excel file. Let's take a look at that here. Here it is. Let's zoom in here a little bit. Okay, so we have all the females. Here's the words, and then down further we have the men right here. So I'll just use the average command. So average. Let's see for the first sample. That's let's see, the cells B2 down through cells B28. Okay, so that is the mean. The mean number of words. I'll just say words for the females. Okay, and what is the standard deviation? So equal sign standard deviation of B2 through B28 again. Okay, so the standard deviation, one more time, the syntax there, standard deviation of B2 through B28, where all the data for the females is, and that standard deviation of words for the females. Okay, very large standard deviation, which is not surprising because we have quite a lot of spread here among the data. Oops, there's something wrong here. We're missing a digit here. It should be 15,357. Oops. Okay, that's going to change a little bit. Hopefully there's no more mistakes here. Let's do a quick check here. 97, 26, 12, 83. Okay, well, I don't see any other obvious problems here. Okay, down to the last one here. All right, so let's go ahead and move on to the males. So just do the average command again. Average of cells for the men, it's cells B29 to B48. Okay, so one more time, I just typed in average. B29 to B48, that's the mean number of words for the males. I'll just say words for the males. Okay, standard deviation, equal sign STDEV of the males, which is, again, that cells B29 through B48. Okay, so there's the standard deviation of the words for the males. All right. So what do you think now? Definitely the mean out of the sample is much bigger for the females than it is for the males. It's 16,000 versus roughly 13,000. So that's some evidence right there that the females talk more. But is that a significant difference? So that's what the rest of the hypothesis test will tell us. Okay, so let's copy those numbers down onto our worksheet here. So let's go. Here, I think I can get both on the same screen. Let's see if I can do this here. Okay, so here we go. So x bar 1 is the mean of the females, which is 16,496. Standard deviation of the females, 7,914. I'll just say 0.3. That's probably good enough. Okay, for the males, the mean is 12,867. For the females, for the standard deviation, for the men, 8,342.5. All right. Now I'm ready to move on to step 3, which is the analysis stage. So part A is get the standard error. And the formula for standard error is that big, long formula. It's the standard deviation of the first sample squared divided by n1 plus the standard deviation of the second sample squared divided by n2. And so in this case, and then the square root of the whole thing. Okay, so in this case, that's going to be, here we go. Here's S1, 7,914.3, 7,914.3 squared. Let me put that in parentheses just to make it look a little better. Divided by n1, which is 27. Okay, plus 8,000, that's S2, 8,342.5. Square all that and divide that by 20, and then square root of the whole thing. Okay, so how do you calculate that? Here's what I do. On my calculator, I'll just square things first. I'll take 7914.3, square that, hit the square button on my calculator, and then hit the divide key and divide that by 27, and then just enter that number and just get whatever. And then do the same thing, square the second part, and then divide by 20 and get whatever. And then add them up together here. So let's get out a calculator. Hold on a moment. Okay, so here's the calculator. Any old calculator will do for this. So I'll just type in 7914.3, square that. We have an x squared button right there. Okay, that's just squared. And then divide that by 27 and equals. Okay, I get this number. I'll just round that there to, let's see, so that's going to be, oh shoot, the calculator disappeared. 2319. The calculator keeps disappearing here. 2319857.2. Okay, plus. Okay, now let's do this calculation. 80, okay, clear. 8342.5, square that, and then divide that by 20. And I get another quite large number there. It's 3479. Okay, come back calculator. 3479865.3. Okay, and now I still have to do the square root of all that. So now just add them together, take the square root, and then I've got my standard error. So one more time here. 2319857.2 plus 3479865.3. Add those together. There we go. And then take the square roots and I don't think this calculator has a square root button, so I'm going to have to get tricky here and take this to the 0.5 power instead. So I'll just hit the exponent button, type 0.5 and equals. Okay, so there it is. The square root, so I add those and take the square root, and I get 2408.3 rounded off. 2408.3. So there's the results of our calculation. That's our standard error right there. Okay, next let's get our t. So this is part B of the analysis stage. So the t score is x bar 1 minus x bar 2 divided by standard error. Okay, so x bar 1 is 16,496, 16,496 minus x bar 2, which is 12,867, 12,867. All right, divided by 2408.3. Okay, calculator time. Okay, let's clear out the old stuff there. So it's 16,496, 16,496 minus 12,867. So that's 3,609. So that gives us the difference between the words for the men and women. But we need to know how was that difference in terms of standard error. So hit the divide key and divide that by 2408.3, and I get 1.51 rounded off, and that's a positive. Okay, so there's our t. Now, what does that number tell us? That number tells us, in terms of standard errors, that back to our raw data here, it is telling us that the sample mean for the females is about 1.51 standard errors higher than the number of words here for the males. All right, and then what's the probability of that happening by random chance? So that's part 3.